Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll perform more integration with logs. So in the first integration with logs videos, we integrated functions of the form y equals a over bx. Now we're just going to apply this more generally to functions of this form. We're going to integrate where we have a function on the bottom and its derivative on top. So this is the formula here. When you integrate such a function on the bottom, its derivative on top, it's just the natural log of the function, whatever's on the bottom. And remember, indefinite integrals, you need to add c. So let's look at this integral here. So here we have a function of x on the bottom and its derivative on top. The derivative of x plus 1 is just 1. So this will just give me the natural log of the function on the bottom, and because it's an indefinite integral, I need to add the c. So there we are, done. So let's try this one now. So here I have a function of x on the bottom. I don't quite have its derivative on the top, however. What I can do is rewrite this. So I'm going to write this as 3 minus x on the bottom. Now, the derivative of 3 minus x is minus 1. So I want there to be a minus 1 on top so I can integrate this using that formula. But I can't just write it like this because 4 and minus 1 are not the same. So what I have to do is I have to write something out the front here to compensate. So what do I multiply by minus 1 to get 4? Well, of course, the answer is minus 4. I can just put a minus 4 out the front because negative 4 times negative 1 is 4. And I can just integrate this and leave the negative 4 alone. So how do I integrate this? Well, I have now a function with its derivative on top. So that just gives me the natural log of that function on the bottom. And I need to add the c. So I had the negative 4 out front, so I can just write the negative 4. I just kind of leave that constant alone. And there we are, I'm done. So how would I integrate something that looks like this? Well, again, I have a function on the bottom, x squared plus 1. The derivative of x squared plus 1 is 2x. So I have a function on the bottom and its derivative on top. So when I integrate it, I just get the natural log of that function on the bottom. Because it's an indefinite integral, I need to add c. So let's do this last question here. I've made this 4 minus 2x squared on the bottom. So I have a function of x on the bottom. Now the derivative of 4 minus 2x squared would actually be minus 4x. Move the power to the front and then decrease the power by 1. The derivative of this is minus 4x. So what I really want is I want this to be a minus 4x on top. Because then I will have a function on the bottom and its derivative on the top. But it's only an x on top. So how can I compensate to make these two equal? Well, I've times by minus 4 here, so I can undo that by dividing by minus 4, or in other words, timesing by negative a quarter. See, minus 4x times by negative a quarter equals x. So these two, this one and this one, are exactly the same, but now this second part here has a function on the bottom and its derivative on top. So the way I integrate that is I take the natural log of the function on the bottom, and I need to add c because it's an indefinite integral. And then this constant out the front, again, I just multiply it at the front and I get negative 1/4. And how easy is that? I'm done. So I just want to make this point again that I made in the previous video. In these two examples, second and fourth example, I moved a constant out the front. You can do that. You can move constants out the front of integrals, but you can never move something out the front of an integral that contains an x. That's not allowed. The reason we're allowed to move constants out the front is because when we're integrating, a constant times a function, we can just integrate the function separately and times by the constant. So you can take numbers out the front of an integral. You can never take out some function of x out the front of an integral. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.